Good morning, students. Today's topic of number system is how we will represent square root 2, square root 3, square root 5 and square root 7 on number line. Number line means we have to represent these all on real line. And these all are the irrational numbers, as these are non-terminating and non-repeating, as well as we can also say these are the square root of every prime number is irrational. Also we can say square root of prime numbers are irrational. So you have to remember this one also. So how we will represent these all on the number line, that is real line. We know that real numbers are the combination of rational as well as irrational, so these numbers must exist on the real line as well. So let us come with the square root first of all. How will we represent square root on the number line? So to introduce this one, we must know about the Pythagoras theorem, and we already know what is Pythagoras theorem. And Pythagoras theorem is nothing but in a right angle triangle, if we have a right angle triangle, then it is right angle at B is some point there, and then if this is your length, you are taking this one as B and this one is your P and this one is your H. You are taking this one as hypotenuse, this one as base, and this one is perpendicular, then your hypotenuse square is always equal to base square plus perpendicular square. You already studied this one, so we'll use this concept in this one. So now we are representing square root on the number line. So let us take a 1 unit. You have to do this with the help of compass, pencil and scale. I am doing this with pen, so you have to do this with pencil and scale and using compass also. So you will take a 1 unit distance, 1 unit length here, and make this as 1 unit and make a 90-degree here. You can make this 90 by using of D also. You can make this by compass also. And what you will do, you will take this 1 unit, you will measure this 1 unit by compass, and you will mark here 1 unit also. These two lengths are equal, then this is 1 unit and this one is 1 unit. You can take any length as 1 unit. Some of the students will ask what length we should take here. You can take any length, any measurement you can take here, and this will be equal to this one here, and you will join this with this. Then by Pythagoras theorem, you know that this length in this triangle ABC, if we know that by Pythagoras theorem that AC square will be equal to your AB square plus BC square, and AC square will be equal to what? Your 1 square plus 1 square, that is 1 square plus 1 square is 1 plus 1, that is 2. It means AC square is 2, therefore your AC is square root 2. So what you will do, you will make this one as here, you will produce this length up to infinite, this is up to going infinite here, and you will mark this length, this point A as 0, this one is 1 here, and somewhere 2 is there, and so on, it is going up to infinite. So what you will do, from compass you will put the point here and you will make an arc here, and somewhere there is a point D, and this length is also square root 2, as we have calculated AC as square root 2. This is length is also square root 2, so the point square root 2 will be here, and this is the representation of square root 2 on the number line. This is going up to infinite, it is 0 here, it could be -1, and these all lengths are equal in length, these all are 1 units. So now we'll make square root 3 on the number line. how we will represent square root 3 on number line. So let us see this one. To represent this one, you will take a length of 1 unit again here, and this is 1 unit, and you will make a 90-degree here on this point B, and this is 90 here, and you will take again 1 unit here, and this is also 1 unit. This point is C. BC is also 1 unit. You can take any length as a 1 unit, and as you done in square root 2, this length will be your square root 2. By using Pythagoras theorem, you can easily find out this one. And at C now, you will taking AC as base. At C, you will make an 90-degree angle here. So by using compass or D, you can make 90 here at C, and since this one is your square root 2, and if you need square root 3, then this, you know that by applying Pythagoras theorem, this the square of this one is 2, so you must have 1 there. So you will take 1 unit here, you will measure this AB length, and you will make an arc. Here is the point D, and CD will be equal to AB also. This one is 1 unit here, and you will join AD, and this AD length you can easily find. AD square will be equal to your, this is by Pythagoras theorem again, and AD square is AC square plus CD square, and AC is your square root 2 square plus CD. You have taken 1 unit again, and this is 1 square. This is 2 plus 1, and that is 3. So you have AD square as square root 3 and AD as again root 3. So you will extend this line up to infinite again, and in the negative side also you will take A as 0, B as 1, then you will take this as 2, and so on up to infinite. You will take minus 1 here, and this is going to infinite. And now this length is square root 3, as we calculated this one as square root 3, and by compass putting one point here, you will make an arc from AD of length AD, and this will cut somewhere here on this line. It is in between 1 and 2 obviously, and this point, this length is also your square root 3, and this point is your square root 3. So square root 3 we can represent like this one. Similarly, if you need to find square root 5 there, then what you can do, you can make an right angle triangle again, taking 1 unit here, AB as 1 unit. Again you are making 90-degree here. This one is also, this point is C, and this is 1 unit, and this AC, you know that this is square root 2 by Pythagoras theorem. Then again you will make 90 at C, and you will take length 1 unit. This point is D there, and this is 1 unit again, and you will join A and D. This length will be your square root 3 as you calculated before. So now what you will do, you will make a 90-degree again at D point, and if you need square root 5, and then we will use Pythagoras theorem there, and to find hypotenuse we must know that the base square plus perpendicular square will be there, and square root 3 square will be 3, so you must have square root 2 here to make that 5. So square root 2, you will measure this length square root 2 AC, and the length equal to AC you will cut here. That point you will take E there, and this DE will be equal to your AC, that is equal to square root 2, and you will join this. So in triangle ADE, you can easily see that AE square will be equal to your AD square plus DE square, and that is nothing but square root 3 square plus square root 2 square, that is 3 plus 2, and that is 5. AE square is 5, then AE is your square root 5. So this length is square root 5, and you can extend this AB line up to infinite. This is going up to infinite. This is 0 there, this is 1, and this is 2, and these all are equal in length. This will be 3, and this is -1, and so on up to negative side. So from point A you will open the compass up to E here, and you will make an arc. This arc will go somewhere here after 2 there, and this is square root 5, and this is also the length will be square root 5, and this point is your square root 5. Similarly, you can represent square root 7 by yourself. That is homework for you, and you will make an activity in book. You have to make their spiral there, spiral of these all. That is the activity in exercise, second exercise. In last question you have there. So that's all we have, that how we can represent irrational numbers on the number line. You will try second exercise 1.2 from NCERT as your homework. So we'll meet in the next class.